In this video, we're going to look at the topic of the inverse of a function. Now, the inverse of a function f undoes whatever the function f does. If you think about it, you're already used to this concept. For example, subtraction undoes addition, and division undoes multiplication. So you're already quite familiar with this idea of one thing undoing what another does, or one function or one operation undoing what another does. Let's go back to our function, our secret identity function that related superheroes and their secret identities. And we said, given the mapping diagram, that we could state y is equal to secret identity of x. And as an example, a specific example, we could give Clark Kent as our y value is equal to secret identity of, and our x value here would be Superman, because they are a matching pair. Now, if you think about it, you could also turn the arrows around. So notice here the arrows are pointing the other way from how they were in the previous diagram, and we've also changed the colors of the ellipses. Now, this side is the x values, or the input values, and this is the output values. And we've got a new function, hero identity. So this new function, hero identity, is taking our input values, which are Clark Kent, Peter Parker, and Bruce Wayne, and giving us as outputs the hero identities of each of these inputs. So now we could write y is equal to the hero identity of x. So importantly, we've got the same matching, or the same pairing going on. Superman and Clark Kent are still paired, but what we've done is we've switched the roles of which one is the input and which one is the output. In the original secret identity function, we had the ones on the left side being the input, and now in the hero identity, we have these ones on the right-hand side being the input, but the pairings are still the same. So the inverse of a function f has the same ordered pairs, the same pairings as f does, except that the input and the output are swapped. So the order within each pair is swapped. The input and the output are swapped. So in the secret identity function, we had Superman as the input, Clark Kent as the output, Batman, Bruce Wayne, Spider-Man, Peter Parker. Remember, the first values are in each ordered pair are the inputs, or the x's, and the second ones are the outputs. Whereas the inverse, which was what we call the hero identity function, still has the same pairing. Superman's paired with Clark Kent, but now Clark Kent is the input and the output is Superman, etc. If we wanted to look at something with numbers, if we had a function which had 1 as its input, 2 as its output, 3 as input, 4 as the corresponding output, etc., its inverse would have the same ordered pairs, except the order would be reversed. 2 is still paired with 1, but now 2 is the input. 4 is still paired with 3, but now 4 is the input, etc. So the inverse of a function f undoes what the function f does, and they have both a function and its inverse have the same ordered pairs belonging to them and belonging to their graphs, except the input and the output are swapped. Now, if we denote the original function as f of x, we can write the inverse of that as f inverse of x. Now, note that you've seen this kind of exponent -1 before, and when you're dealing with numbers, it means the reciprocal. But when you're dealing with functions, it doesn't. It means the inverse. So it's important to know that f with a little -1 does not mean 1 over f of x. It means the inverse function of f of x. Okay, let's look at a quick example. Given a function f of x and its inverse, f inverse of x, if f of 3 is equal to 5, what's f inverse of 5? Well, remember that this is saying when the x value is 3, the y value is 5 on the original function. The original function has the point 3, 5 on it. Well, remember that on the inverse, the ordered pairs are all the same except their order is swapped. So the inverse will have the point 5, 3 on it. When the input on the inverse is 5, the output will be 3. So that means that f inverse of 5 is equal to 3.